Welcome to our foundational course on cybersecurity operations. In this video, we will explore the essential components, technologies, and processes that make up a Security Operations Center, or SOC. This training is designed for absolute beginners, assuming you have zero prior knowledge of this vital topic. Let's get started by defining what a society actually is. A Security Operations Center, or SOC, is basically the command center for cybersecurity in a company. Think of it as the central guard station, staffed by security experts. Their job is to oversee and manage the organization's entire security position. The main purpose of the SOC is to protect the company from cyber threats and maintain the integrity, confidentiality, and availability of all important data. These three elements, confidentiality, integrity, and availability, are often called the CIA triad. A major responsibility of the SOC is continuous monitoring. They watch the network and systems around the clock, 24/7, searching for any unusual activity or potential threats. The work of the SOC is guided by four main functions. First, they identify a potential issue and open an incident. Second, they investigate the root cause and impact of that incident. Third, they mitigate the problem, meaning they recommend actions to isolate and remove the threat. Finally, the process involves continuous improvement, constantly adapting technology and procedures based on what they learn from each incident. This structured approach ensures the organization stays resilient against constantly changing threats. The people inside the society are structured into specialized roles to handle threats efficiently. This often uses a tiered model to ensure quick response and thorough investigation. At the entry level, we have the Tier 1 triage specialist. Their crucial job is continuous monitoring, collecting raw data, and reviewing the constant stream of alerts. They decide if an alert is real or a false positive. This is vital to reduce alert fatigue. If they confirm a legitimate issue, they escalate it to the next tier. The Tier 2 incident responder takes over high-priority incidents. They perform a deep dive investigation, using threat intelligence to understand the attack's scope. They are responsible for designing the immediate response, focusing on containing the threat, and recovering affected systems. The most experienced team members are often the Tier 3 threat hunters, or specialists. They proactively search for hidden threats that bypassed initial defenses. This is called threat hunting. They also handle the most severe incidents and suggest how to improve the overall security tools and procedures. This diagram illustrates the typical tiered structure of a Security Operations Center team. At the top is the society manager, who has the critical responsibilities of managing the team, ensuring adherence to security policies, and communicating security status to executive leadership. Below the manager are the three operational tiers. Tier 1, the triage specialist, is the frontline defense. They continuously monitor and filter the massive amount of incoming security alerts, distinguishing between real threats and harmless events, also known as false positives. When an incident is confirmed and requires a deeper look, it moves to Tier 2, the incident responder. Tier 2 analysts conduct detailed investigations to understand how the attack happened and immediately focus on containing the threat to limit damage. If the incident is complex or major, it is escalated to Tier 3, the threat hunter, or specialist. Tier 3 performs deep analysis, conducts proactive threat hunts, and works to optimize the security tools used across the entire society operation. The key is the continuous feedback loop, where Tier 3 refinements circle back to improve Tier 1's monitoring capabilities. We now turn our attention to the foundational technology that enables this structure, the Security Information and Event Management System. Now we move to the core technology that powers the society, Security Information and Event Management, or SIEM. Imagine your network generating thousands of security messages every second from firewalls, servers, and applications. SIEM acts as the central brain that collects all this information. First, it performs data aggregation and normalization. This means it gathers data from every source and converts it into one common, unified format. This step is critical because it makes the data easy to analyze. Next, the SIEM system performs real-time correlation. This is the most powerful part. It looks for patterns and links together seemingly unrelated events. For example, a single failed login attempt might be harmless, but 100 failed logins, followed by a specific network scan, are correlated by the SIEM to flag a coordinated attack. When the SIEM spots a potential threat based on these patterns, it generates an alert based on how serious and urgent the threat is. Finally, SIEM keeps a long history of these logs, which is vital for forensic investigations and meeting legal compliance requirements, such as GDPR or HIPAA. While SIEM gives a broad view of the entire network, the SOC also needs deep visibility into individual devices, which we call endpoints. This is the job of Endpoint Detection and Response, or EDR. Endpoints are devices like laptops, desktops, and servers, and they are often the main targets for cyber attackers. EDR works by installing specialized software agents directly onto these devices. These agents provide continuous monitoring, constantly collecting detailed data about everything happening on that device: file changes, process execution, and network connections. EDR uses behavioral analysis and machine learning to establish what is normal for a device. Any deviation, such as a process running from an unusual location, triggers an alert. EDR also scans for known attack footprints, called indicators of compromise, or IOCs. Crucially, EDR enables automated response directly on the device. For example, if malware is detected, the EDR tool can automatically quarantine the infected laptop from the rest of the network to prevent the threat from spreading. EDR data provides the deep forensic information necessary for security teams to understand exactly how an attack started and unfolded. We have seen how SIEM and EDR detect threats. But when threats pour in constantly, analysts get overwhelmed, a condition called alert fatigue. To solve this, SOCs rely on security orchestration, automation, and response, or SOAR. SOAR is the technology that helps machines do the repetitive work, freeing up human analysts for strategic tasks. SOAR does three main things. Orchestration connects different security tools like SIEM and firewalls so they can talk to each other seamlessly. Automation is the machine-based execution of security tasks, often without human help. Response defines the automated actions taken against threats. The core mechanism of SOAR is the playbook. Think of a playbook as a recipe, a step-by-step, documented set of actions that runs automatically when a certain type of alert is received. For instance, a playbook might automatically take a high-severity alert from the SIEM, enrich it with threat intelligence data, block the suspicious IP address on the firewall, and then notify the analyst all in seconds. This capability dramatically reduces the mean time to respond, MTTR, and minimizes costly human errors. A modern society doesn't just wait for alerts to happen. It uses a proactive approach to find threats before they cause damage. This involves two critical activities. First, we use cyber threat intelligence, or CTI. CTI is information about who the attackers are, what motivates them, and how they operate, known as tactics, techniques, and procedures, or TTPs. A core piece of CTI is the indicators of compromise, or IOCs. IOCs are the digital footprints or clues left by attackers, like a suspicious domain name or a unique file signature. The SOC integrates these IOCs into their security tools to automatically scan for known malicious activity. The second proactive activity is threat hunting. This is a human-led activity where experienced analysts actively search the network for subtle signs of an intruder that the automated systems missed. Threat hunting relies on forming a hypothesis, such as, an attacker is moving laterally using a specific type of file transfer, and then manually searching through logs to prove or disprove it. Hunters often use the MITRE ATT and CK framework to map their searches to known adversary behaviors, making the hunt structured and effective. This diagram shows the continuous loop of proactive security adopted by modern SOCs. The cycle begins with cyber threat intelligence, or CTI, which provides external information about current threats, including indicators of compromise IOCs, and tactics, techniques, and procedures, TTPs. This intelligence informs the threat hunting process. Threat hunting is a proactive, human-driven search where analysts build specific hypotheses about potential intruders inside the network. These hunting activities are often structured using the MITRE ATT and CK framework. This framework helps analysts categorize and visualize specific adversary behaviors, ensuring the team hunts for relevant techniques used in the real world. The confirmed findings from a threat hunt lead to detection refinement. This means the society creates new, specific detection rules for tools like SIEM and EDR, instantly improving the overall defense capabilities. These refined detections, in turn, feed back into the overall CTI data, restarting the continuous loop of defense improvement. All these proactive and reactive measures must be managed through a disciplined process, the incident response lifecycle. Even with the best technology, security incidents will happen. The SOC must follow a clear, structured plan called the incident response lifecycle. This plan ensures a fast and coordinated reaction to minimize damage. The first phase is preparation. This happens before an attack, involving developing policies, training the team, and ensuring all tools and logs are ready. When an attack occurs, the identification phase begins, where the SOC confirms the incident using alerts and tools. Next comes the most critical step, containment. This means isolating affected systems immediately to stop the attacker or malware from moving further inside the network. Once contained, the eradication phase removes the root cause, such as malware or unauthorized access. The recovery phase restores systems to normal operations, often using secure backups, and verifies that no vulnerabilities remain. Finally, lessons learned involves a post-incident review to analyze how the attack succeeded, identify the root cause, and update the response plan to prevent future incidents. While the tools we discussed are powerful, traditional SOCs face major challenges. Massive amounts of security data are siloed or trapped in separate tools, leading to analyst overload and slow responses. To counter this, the future of the SOC is moving toward an AI-driven autonomous approach. This evolution is represented by platforms like Extended Security Intelligence and Automation Management, or XSIAM. XSIAM fundamentally changes the way security works by unifying many different security functions like EDR, CM, and SOAR into a single converged platform. Instead of manually switching between many consoles, XSIAM uses artificial intelligence and machine learning as its foundation. It continuously collects and stitches together massive volumes of raw security data, building a complete, correlated picture of an incident automatically. This machine intelligence handles the bulk of low-risk, repeated alerts and investigations. The main benefits are simplified operations, reduced complexity from disconnected tools, and dramatically accelerated incident remediation, reducing the mean time to respond, MTTR, and enabling human analysts to focus only on the most urgent, high-impact threats.